Hello there, welcome to video number 197. This one is on line graphs and frequency polygons. They are effectively the same thing. Keywords are plot, midpoint, variable, frequency, time series. So to plot something is to mark on the graph with an X in the correct place according to the X and the Y values that you are given. The midpoint of something is halfway between it. The variable is something that is changeable. Frequency is how much of something there is, or how much something's worth, and then the time series is a particular type of one of these graphs where you will have a unit of time along the x-axis and frequency or something up the side. But the time series graphs show a particular trend in the data. Okay, so I'll get to that in question number 2 shortly. So the first thing that I'm going to talk to you about is the method, which is written here. To represent given data in a line graph, you need to be able to plot points in graphs. Hopefully something you can do by now. The variable is represented on the x-axis and the frequency is represented on the y-axis. Regard the data and plot the given information into the graph. You may need to sort the scale out sometimes for yourself, and join the points up with straight lines and then draw conclusions from the graph if required. If you're doing a frequency polygon, you've got class widths in the data that you've got. You're going to plot at the midpoints there as well, just to make a note of that. All right. Again, I'll show you in question 2 what we're doing there. Now, I'm going to first of all move myself over so I can zoom into question number 1, and hopefully you'll be able to see it better. I might cover part of the table of information, but I can read that out and hopefully you can see the graph. Okay, so try and zoom in there. Oops, wrong place. Didn't want to zoom in there. Wanted to zoom into question number 1. There we go. So draw a line graph for the following data. This is all about days off and how many days off, how many times people have had those numbers of days off, right? Not much context, but a little bit. What we're going to do is going to try and plot some points. And 0 days off 18 times. So plot that at 0, 18. 1, 6 needs to be plotted. 2, 11 needs to be plotted, and so on. All right, 3, 4, 4, 3, and 5, 7. So once we've plotted those points in the graph, you should be using a pencil and to plot these points, a sharp one, and using X's. I can't on the computer because it doesn't like me drawing the X's for some reason on this particular tool. What I'm going to do is get my ruler and my pencil, or my equivalent of, and join those points up that I have drawn. That is now creating my line graph. Just about gets to that one, and then that last one seems to have disappeared. Don't know why, but there we go. So there's my line graph that I've drawn according to the data that I've been given. Happy days, good times. Right, not the most complicated of examples, but the first question never is. Now the second one, I've got, again, I might be covering a bit of it over with my face, but question 2 asks us to draw a frequency polygon for the following data, and the data I've been given has been recorded by whoever's worked it out in class widths. So the time that's been recorded in seconds is between 0 and 5 seconds. So we take the midpoint of that as our x-axis value to plot each one of these. So that's going to be 2.5, 7.5, 12.5, etc. And then we're going to plot them at their respective frequencies, or temperatures. So that's going to be 2.5, 10. 2.5, 10 is there. Then 7.5, 35, which is there, and then and again do it with little x's. 12.5 needs to be at 15. 15 is there, and then the next one is 17.5 at 40. That's there, and so on. All right. Hopefully you get any idea of what I'm doing by now without me having to say it. So it goes 25, and then at the last one, 27.5 at 18. That is a little bit trickier because there's 20, there's 18, there's 15, so there's roughly 18 there, just below 20. Okay, so sometimes you have to be a little bit less accurate than you would like to be, but there we go. We're going to join those points together and create our frequency polygon. All right, and the last one's disappeared again, but it would have been about there, so let's go with that. Okay, so there we go. We've got my frequency polygon there. That's part A done. Now, in part B, you might not be able to see it, but estimate the temperature at 20 seconds. So 20 seconds is here, right? What we do is we take a line and we draw a little trend line. So what we can see is that whatever this is about, the temperature goes up and then down, but very slowly over time, the temperature is rising slightly, right? So what we do is we take a line, it's called a trend line, and we just draw it through. We whack it through those values like that. Okay, it might not be the best example because it's not got that many seconds to create a trend, but we might get an idea then of an estimate of the temperature at 20 seconds. All right, so at 20 seconds we might be saying it's likely to be whatever that value there is. Okay, so I'm going to go up maybe with a different color line here, and you could draw this on there with your pencil and ruler. Go across there and find out what that particular value is on the temperature scale. So I'd say that's probably 22, 4, 6, 8, 28 maybe. That would be fine. And we'd write that in our space there. Okay, so I'm going to zoom out, and then that is unfortunately going to disappear. But remember that the data that we are writing, hang on, how can I come out of that? I'll get back onto my normal pen. Yeah, that would be, let's say, 28 degrees. Okay, so it gives you a little bit of an idea of a trend. Okay, and you might get, I don't think there are any questions on moving averages these days, right? But if we were talking about the 4-point moving average, we'd get a good idea of the trend over a period of time. Sorry, these pop-ups keep coming up on this particular video, which is also frustrating me. Never mind, we'll move on. So, question 3. Gavin asked his mates how long they spend on their phone per day. How many people did he ask? So what you can see here, up the size, the frequency, what we're going to do is look at those and we're going to add them together. So 20, 35, and then whatever that number is, that's hard to see. So maybe I'm going to have to zoom into this one to have a look. Again, change back to that. And then zoom in over here at the graph. And yeah, let's have a little look by drawing that on there. I can see that actually is 28. Okay, so I'm going to get my calculator in for this because I can't be faffed to work it out. In fact, the calculator doesn't pop up when I've zoomed in. That's annoying. I'm just going to use my calculator I've got in front of me. So we're going to go 20 plus 35 plus 28. So there's my first 3 numbers. This one is 10, 11, 12, 13, I think. So we'll add 13 there. Again, you'll be able to see this a bit clearer, not on the computer. That one looks to be at 4, so plus 4. And then at this number 5 hours here, people that spend 5 hours a day on their phone, 2 people. Okay, so add the 2. Right, 102. That's what that one is. So I'm going to zoom out of that. And there we go. I'm going to write down that it is 102 people. All we've got to do is look at what these are at the heights of their frequencies and then add them all together to get the total number of people. What's the range of hours? Well, the range of hours is between 0 and 5. So 5 take away nothing is 5. So there's our range. That's quite a nice simple one. And what percentage of his mates spend more than 3 hours on their phone per day? So more than 3 hours is 4 and 5, right? Remember that was 4 people and 2 people. So that's 6 people out of, and then what we've got is the total number of people, 102, which is annoying because it's not out of 100. So we have to do that on the calculator, and I could bring the calculator in now because you should be able to see it. And we will get 6 out of, or divided by 102, 2, and that equals 1/17, and multiply it by 100. That will turn it into a percentage for us. There we go, so 5.88%. So it's very close to the 6 because it's very close to 100 on the bottom there. Okay, so we're going to say 5.9% if we're going to be round it off to 1 decimal place. All right, hopefully that makes sense to you. Got a few little extra questions there in part 3, but mostly it's about plotting some points, joining some lines together, and making sure on frequency polygons, if it's class width data, you make sure you plot at the midpoints. And that's it. Hopefully you've enjoyed that video. Thanks very much for watching. Take care of yourselves. Bye bye now.